So what we were dealing with last class is we were doing our graphing of our quadratic function. So let's take a quick look at that again. So here's my graph. Let's say here's my parabola. So first we got to remember these are what we call our roots, our zeros, and our x-intercepts. So the part we're focusing on today involves your vertex, which can either be a maximum or a minimum. In this example here that I've drawn, this one's a minimum. And then also your axis of symmetry, which remember is that imaginary line that goes right through the middle of your parabola, breaking it directly in half. So the axis of symmetry is always an x equals a number because it's a vertical line. So if you remember, that number always matched whatever the x value was of your vertex. So let's say this is at x equals 3. My vertex could be the point 3, negative 1. So your axis of symmetry and that x value and your vertex are always the same. So what we're doing today is we are finding that axis of symmetry and that vertex algebraically this time. So first thing we have to remember is putting our equation into standard form. You're going to get in this habit, this unit, and hopefully going forward, you always want to put it in standard form. So you've got your x squared term first, and then your x, and then your c. So the one we have to find first is your axis of symmetry. You can't find your vertex without finding your axis of symmetry. So that's our formula, x equals negative b over 2a. And you're going to have to memorize that formula because you're not going to be given that one. So we get the b and the a when we are in standard form by looking at our equation that we're given. Our a is in front of your x squared, your b is in front of your x. So once you have your axis of symmetry, you can then find your vertex, which is also referred to as the turning point of the parabola. And the coordinates of that would be negative b over 2a, which just means that's your value from your axis of symmetry. So we'll put that little note here. That's your axis of symmetry. And then it's comma y. You get your y value by plugging in your axis of symmetry value. So let's take a look at a couple examples. It makes it a little easier when we do some examples. So we're told to find the equation for the axis of symmetry and the coordinates of your vertex algebraically. So as I said, we got to do axis of symmetry first, which is the formula x equals negative b over 2a. And you want to write that formula every time because that's what's going to help you memorize it. So if we look back at our original problem here, we need to know two things from it. We need to know our a value and we need to know our b value. So again, the a value is the number in front of your x squared, which in this problem would be a negative 1. Your b value is the number in front of your x. So in this case, our b value would be a 6. So now I can go ahead and plug that in. So I'm going to have a negative 6, because I have negative for my equation, plugging in my 6, and then 2 times negative 1. So I get negative 6 over 2 times negative 1 is negative 2. So x equals 3. That is my equation for my axis of symmetry. And you have to write it that way. You can't tell me just a 3. They want an equation. An equation has an equal sign. So now we can go ahead and find our vertex. So we take our original equation. And what we're going to do is we're going to plug in what we just got for x in for x. So it's going to be negative 3 squared plus 6 times 3 minus 5. So 3 squared is 9, but then we got this negative sign out in front here. 6 times 3 is 18, and then minus 5. So when we subtract this, negative 9 plus 18 is 9, minus 5 gives us a 4. So our vertex is going to be the point 3, comma 4. So let's try this again. So finding axis of symmetry first. I'm going to start with writing my formula, x equals negative b over 2a. So then I'm going to go up here, figure out what my a and my b values are. So again, a is in front of x squared, so my a would be a 1. B is in front of your x, so my b in this time is a negative 3 because it's a minus there. So plugging in, I get negative 3 over 2 times 1. So when I do negative, negative, that turns to positive. So I've got a 3 over 2, which if I divide 3 by 2, I get 1.5. So this time our axis of symmetry is a decimal, which does happen sometimes. Remember last class, that was the one we couldn't find on the calculator because our table didn't do decimals. So sometimes it does end up being that. So let's find the rest of our vertex. So I'm going to take my 1.5, plug it in for x. So 1.5 squared gives me 2.25. 3 times 1.5 gives me 4.5. So when I subtract, 2.25 minus 4.5 gives me a negative 2.25. So our vertex is the point 1.5 comma negative 2.25. Now these next two questions are other kinds of questions that tend to be asked regarding your axis of symmetry and your turning point. So you don't have to do all of the work we did up above because they give you one part of it. You're just trying to find something else. So for example, number 2, x equals negative 3 is the equation of your axis of symmetry. So that's saying they already did that first part for us. They found our axis of symmetry. We don't have to do our negative b over 2a. All right, so x equals negative 3 is the equation for the axis of symmetry of this graph here. They want to know what is the y-coordinate of the turning point. So as I said, this first part that we did on these two problems has already been done for us. They got x equals negative 3. They want the y-coordinate, so all I have to do is plug in that negative 3 for my x. So negative 3 squared gives me positive 9. 6 times negative 3 gives me negative 18. And then plus my 10. So 9 minus 18 is negative 9. Plus 10 gives me a 1. So my y-coordinate would be 1. Y equals 1. This next one, number 3, they gave us this equation here, which if you notice, this equation is a little different because it's got a k at the end there. So we have this parabola whose equation is this, has a turning point with coordinates of 1, negative 5. They want us to find the value of k. So since we know this is the turning point, and since it is a normal point, that means 1 is an x value, negative 5 is a y value. It's always x comma y. So what we're going to do is we're going to plug those numbers into here, and then we'll be able to find our k. So instead of y equals, it's going to be negative 5 equals, and then it's 1 squared minus 2 times 1 plus k. So 1 squared is 1, 2 times 1 is negative 2 plus k. So negative 5 equals 1 minus 2 is negative 1. And then add my 1 over. So negative 4 equals k. And there we go. Now our other topic for today is the vertex form of a quadratic function. Vertex form is just another way of being able to write your quadratic function other than using standard form. Now the reason we have vertex form is when you look at vertex form, you can immediately pick out what the vertex is. So we'll see some problems later on in this unit when this is very helpful to us. So for now, what we're going to do is we're just kind of slowly start practicing putting it into vertex form so that we can later see the application of it. So here is our vertex form. Lots of letters involved in there. So f of x, that's just our standard function notation. This a value here is the same as your other a value when we're in standard form. So that's the same thing. That's why they use the same letter. It's the same thing. So whatever's in front of your x squared in your standard form is what we put in front of this. And then your h and your k get taken out to make a point, and that point is your vertex of your parabola. So there's a lot of different little pieces here. So let's take a look at an example. I have y equals 2 times x minus 1 squared plus 5. So what happens is, in our original equation up here, it was minus h. So when I take this number out to make an h, I change the sign of it, so it becomes positive 1. So h is positive 1. Whatever number at the end is your k. So that means our vertex is the point 1, 5. So if we look at the next one, to be able to find our vertex, again, change the sign from when you take it out of the parentheses. So that would become negative 4. And then when you're not in the parentheses, that stays the way it is. So negative 4, negative 6 becomes your vertex for that one. So again, vertex forms allows us to see that quickly. So writing a quadratic function in vertex form, you want to first graph it on your calculator, because that helps us get the coordinates of your vertex. You are welcome to calculate it algebraically if you want to, but you don't have to. You can just use your calculator to actually find your vertex. A time when you may have to calculate it algebraically is if your vertex is a decimal. That's the only time we would have to do it that way. So then you want to plug in your h and your k into your vertex form and note if the parabola opens up or down. So let's take a look at this. We're writing the function in vertex form for the quadratic pictured below. So first thing I'm going to do is I'm going to write my generic vertex form, because as I said, more times you write something, the more you're going to remember it. The 3 pieces of information we need to know to plug into there are your a, your h, and your k. So let's go over here and take a look. Here's our vertex. The coordinates of your vertex would be 1, negative 3. And that right there gives us 2 of our letters. The x value from your vertex is your h. The y value is your k. So we have our h and our k already. Now a little trick I'm going to tell you. For right now in Algebra 1, your a will always be 1 or negative 1 when given a graph. And that's only when you're given a graph. If it's not a graph, it's going to be different. But as I said, for Algebra 1, if you're given a graph, it's either 1 or negative 1. Now the way we tell which one it is based on which way is our parabola opening. Now this one, both our ends are going up, so our parabola is opening up. So this one is a positive 1. If our parabola were opening down, kind of like this, that would be a negative 1. So now that I have my 3 unknowns, I can go ahead and fill them in over here. So it would be 1 and then x minus 1 squared plus a negative 3. Now we could leave it like that, but we don't have to have the plus and negative 3, so a lot of times what happens is they clean it up and they change that to just minus 3. So you just got to recognize this, that, those are the same exact thing. Okay, let's try the next one. So again, first thing I'm going to do, write my vertex form, my generic one. And our 3 things we need to know are h, our a, and our k. Okay, so this one, they gave us the equation this time. They didn't give us a graph. So if we look at our equation, look at the a value of our equation, it's a negative 2 So when we write our vertex form, our A is still going to be a -2. So let's have you go ahead, type this into your calculator, just as it is, and see if you can find your vertex. What we can also practice doing is finding our vertex algebraically. So our B value here is a -4, so we're going to have -4 over 2 times -2. So that gives me 4 over -4. So x equals -1. So I've got my first part of my vertex. So now I just need to plug in my -1. So -1 squared is 1, times 2 is -2. -4 times -1 is +4, minus 2. So -2 plus 4 is 2, minus 2 gives us a 0. So our vertex would be -1, 0. So that means my h is -1, my k is a 0. So plugging everything in, a is -2. Then we'd have x minus -1 squared plus 0. But we have to clean this up a little bit. So minusing the -1 really means it's going to become x plus 1 squared. And then the plus 0 at the end, you don't have to write that. So that would just end up being our final answer.